This comes out of section 9.3, problems involving motion, velocity, acceleration, etc. So this problem, we've got a particle accelerating in a straight line so that its velocity in meters per second is equal to the square root of time elapsed. And the question is, how far does it travel in the first hour? So let's use our v for velocity, s for position or displacement. In this case, we're given v. We're told that v equals the square root of time. Probably a slightly more useful way to write that is to say ds by dt equals t to the 1/2. Remembering that velocity is just the derivative of your position time function. So if I want s equals, I can take the antiderivative of this. Now, when fractions get involved, people have a bit of trouble sometimes. But so if I add 1 to the exponent, I'm going to have t to the 3/2, or 1.5. But then I would have to divide by 1.5. Another way of saying that is 2/3 t to the 3/2, and then plus a constant if I'm doing the most general antiderivative of this thing. The fact is that constant, as you'll see, turns out to be kind of irrelevant because we're asked here, how far does it travel in the first hour? So first of all, 1 hour is 60 seconds times 60 minutes, so we have 3,600 seconds altogether. You might just know that off by heart. So even if I say, well, what's my position at 3,600? Even if I leave the c in there, I'm going to have 2 times 3,600 to the 3/2 divided by 3 plus c. My position at 0 is 0 plus c. So my change in position in an hour is going to be the difference between those two. And the point I'm trying to make here is that the c really doesn't matter because you'd be subtracting the constant anyway. So we can assume that this thing starts at 0, in which case we don't have a c, or it could have started at 5 meters, but we'd be subtracting the 5 meters from the original answer anyway. So it travels this 2 times 3,600 to the 3/2 divided by 3, which is like 144,000 meters, or if you prefer, 144 kilometers in the first hour. The most important piece of that, or the piece as far as it relates to this chapter, is just being able to do this antiderivative here, to be able to say, oh, okay, I can use the power rule in reverse from my table of integrals, table of antiderivatives.